Hey everyone, here's our math problem for today. This is a problem given in Ukrainian Math Olympiad. We are asked here to find the real roots of this polynomial equation. X to the fourth minus 7x cubed plus 14x squared minus 7x plus 1 equals 0. When we are asked to solve for any equation like this, there are some preliminary steps that we would like to perform before actually solving the problem. First is we look at the coefficients. Is there any pattern in the coefficients? Notice that you have here 1 and 1 here. You have negative 7 and negative 7 here, and you have positive 14. Since the distribution of the coefficients are balanced, we say that this is a symmetric equation. Also, we look at the highest degree. The degree of the leading term here is 4, and so we expect that there must be 4 complex roots in this equation. Those roots could be all real numbers, or it could be combinations of real and imaginary numbers. Also, it helps if we can visualize the equations. Using Desmos graphing calculator, here is the graph of the Quartic polynomial equation. Luckily for us, there are 4 points of intersections between the x-axis and the red curve, indicating that there are 4 real roots for this equation. And those 4 real roots are this point here, there's another point here, and there's another point here. And that is what we would like to find as we solve this 4th degree equation. So let's solve this problem together. Let's look at these terms here with variable x. What will happen if we replace x by 0? The answer is this entire 4 terms would become 0, and what's left is 1 equals 0, which is wrong. This means that in this case, x cannot be equal to 0. And that is important because that will allow us to perform division by x or any power of x, because we know that we are not dividing by 0. Because of that, we will be able to lower down the degree of this equation by dividing each of the terms by x squared. Anyway, we know that x squared is not 0, so division by x squared here is valid. Simplifying, x to the fourth divided by x squared is x squared, minus 7x cubed divided by x squared is minus 7x, plus 14x squared divided by x squared is 14, minus 7x divided by x squared is minus 7 over x, and we copy 1 over x squared equals 0. The leading term now here has a degree of 2, so if we can find a way to substitute variable for these terms with variable in the denominator, then there is a way for us to just work with quadratic equation instead of working with this 4th degree equation. And we have more tools in solving quadratic equation, like factoring method, like the quadratic formula. So that is the direction of our solution here. Convert this 4th degree equation into a quadratic equation using variable substitution. Before that, let's rearrange the terms here so that those terms with x squared are together, those terms with variable x are also together. Notice also that there's a common factor of 7 here. So let's perform all the simplification that is possible first. So factoring out negative 7 in these box terms, this is the result. If you distribute this negative 7 to this binomial, you will go back to the original equation. So we have this term x plus 1 over x. Let's use a variable in place of this expression x plus 1 over x, and let's use the variable a for x plus 1 over x. That way, this entire binomial cannot be replaced with the variable a. But we still have complicated expressions here, x squared plus 1 over x squared. Now, to have x squared, let's try squaring x plus 1 over x, and let's see what will happen. So squaring this, we have to square the first term plus twice the product of the first and the second terms plus the square of the last term. So simplifying, we copy x squared. 2 times x times 1 over x gives us 2, which is now this middle term. And of course, the square of 1 over x can also be written as 1 over x squared. Why are we doing this? Notice that this x squared and this 1 over x squared are these 2 terms. There's just an extra constant of 2, but these 2 terms that are here are exactly these 2 terms at the bottom. So all we have to do is subtract 2 from both sides so that we can have x squared plus 1 over x squared at the right side, which is exactly these first 2 terms. Now we know that x plus 1 over x is simply a. So let's do also the substitution here. And therefore, we now know that this x squared plus 1 over x squared, which are these first 2 terms, cannot be replaced by a squared minus 2. So let's do the substitution now. So we now have a squared minus 2 in place of these first two terms, and we just copy all the rest. Then minus 2 plus 14 simplifies to plus 12, and we now have here a quadratic equation that can be solved by factoring. So using the tic-tac-toe method, the factors of a squared are a times a. The factors of 12 that will result to negative 7 when added are negative 3 and negative 4. Or it could be other combinations. To check what are the right combinations, let's multiply. A times negative 4 gives us negative 4a. A times negative 3 gives us negative 3a. And negative 4a plus negative 3a is negative 7a, which is exactly this middle term here. So we know now what are the factors. We have a minus 3. The other factor is a minus 4. And that is equal to 0. Now, using the zero product property, each of these factors can be equated to 0, and solving for a equals 3, and in here, a is equal to 4. But we are not after the value of a, we are solving for the value of x. So we need to do backward substitution now. We know that a is equal to x plus 1 over x, and since both of them are equal to the same quantities, then we now arrive at these two equations. X plus 1 over x equals 3, x plus 1 over x equals 4. Again, there's still a variable x in the denominator which we can eliminate by multiplying each of the terms by x. So multiplying by x times x gives us x squared, x times 1 over x gives us 1, 3 times x gives us 3x. Then let's write this in the standard quadratic form. Similarly, at the right side, we multiply each of the terms by x to get x squared plus 1 equals 4x. Let's rearrange the terms so that we can have the standard quadratic form. These two equations are not factorable, so we are going to use the quadratic formula. Here, our a is 1, our b is negative 3, and our c is 1. Substituting those values for a, b, and c to the quadratic formula, this is now the result. We have x equals 3 plus or minus the square root of 9 minus 4 times 1 over 2 times 1. The radicand here simplifies to 9 minus 4, which is equal to 5. So we have 3 plus or minus the square root of 5 over 2. Then for the equation at the right side, our a is 1, our b is negative 4, and our c is positive 1. Substitute that into the quadratic formula, and here is the result. Then 16 minus 4 is 12. And the square root of 12 is simplified as 2 square root of 3. There's a common factor of 2 here. This finally simplifies to 2 plus or minus the square root of 3. So going back now to our main problem, the roots of the equations are these 4 roots. 3 plus the square root of 5 over 2, 3 minus the square root of 5 over 2, 2 plus the square root of 3, and 2 minus the square root of 3. And so going back to our visualization at the start, here is the graph of the given quartic polynomial. There are 4 intersections between the x-axis and the red curve, and those 4 intersections correspond to the 4 roots of these equations, namely 3 plus the square root of 5 over 2, which is approximately 2.618, which is this point here. The next one is 3 minus the square root of 5 over 2, which is approximately 0.3819, which is this point. The next one is 2 plus the square root of 3, which is approximately 3.732, which is this point here. And lastly, 2 minus the square root of 3 is about 2.679, which is this point here. So these are the 4 roots of this given quartic polynomial, and this problem is now solved.